We are working on the scenario BMI and your health. Of course, the first thing you have to do is make sure you put your name in. We are going to talk about calculating your body mass index, determining a healthy BMI, analyzing the BMI formula and comparing it to the data it represents, calculate your ABSI, a healthy BSI, and the data it represents, and then decide which of those two is a better represents the data. We're going to calculate using a formula, convert measures, analyze data, and compare trend lines. You're probably familiar with the term body mass index, or BMI. In a nutshell, it's a formula that compares your weight to your height. BMI doesn't tell you anything about where you're carrying your weight, and that's key because numerous studies indicate that carrying excess belly fat or being apple-shaped is more risky to your health than being bottom-heavy or pear-shaped. That's why researchers at City College of New York developed a new formula, ABSI. When the researchers took data from the U.S. sample of over 14,000 non-pregnant adults, crunched the numbers and compared them with mortality rates for the same group, they found some interesting results. High death rates were correlated with both low and high BMI, but ABSI predicted premature death regardless of other factors like sex, ethnicity, and smoking. By the way, smokers weigh less than people who don't smoke cigarettes. In other words, even if you're young with a normal BMI, you may be at greater risk of dying sooner if you carry more weight in your midsection relative to your height and weight. And there's the ABSI formula from the ScienceTodayDaily.com. Here we go. We are supposed to, as one of our core abilities, be able to develop self-awareness. Knowing your body is one way to increase your self-awareness. The purpose of this exercise is not to pry into your personal matters, so if you want to give a fake height and weight, the calculations won't change. BMI is calculated in metric units. Divide your weight in kilograms by the square of the height in meters, and there's the formula right there. If you don't know your measurements in the metric units, you will need to convert them. To find your weight in kilograms, multiply your weight in pounds by 0.4535924 and your height in meters by 0.0254. So my weight in pounds is 191. My height in inches is 74. To find my kilograms, I'm going to take my weight in pounds, and then it says times 0.4535924. And for my height in meters, I'm going to take my height in inches times 0.0254. So my BMI is my weight in kilograms divided by my height in meters squared to the second. So that's shift 6 to the second. And my weight, or my BMI then, is 24.5. And if you notice, that puts me in the normal weight category. All right. Barely perceptible in the BMI graph to the right is that the data are best represented by a curve, not a line. I'm going to see if I can zoom in for you on the graph so that you can see what I'm talking about here. If you notice, the line is a little bit below the data points at the ends, and the line is a little bit above the data points in the middle. So basically what it's saying is the actual data for BMI are curved compared to a line, even though the formula is an even line. So this is for BMI equal to 22. For those people, and you see the mass in kilograms. The two ends of the graph are above the line, and the middle is below the line. So a tall and short person would have a slightly higher BMI calculation than may be right for their body size. The cause of the curve is that the height should be cubed in order to make the line with mass. If we curved that, or if we cubed the height, we would have a straight line. The images on the left and right are real-size images of two men. They show the proportions. Okay, so you see the pictures here of the two men. If we were to stretch the shorter man out, you can see that his proportions are way different if he's stretched out than if he's normal size. In other words, what happened as you stretch somebody out is their legs grow much faster than the rest of their body. The science of what happens as we grow is called allometry. I think the best example is that your head is 1/3 your height when you're born. Can you imagine carrying around a head that would be that big? You'd have to, like, hold up your head with your hands in order to have it work out right. One of the biggest problems for using BMI is that it doesn't accurately depict a person's chance of dying, his mortality. After all, why would you care what your BMI is if it didn't affect your life? The data at the right shows the BMI percentile, or Z-score, plotted against the mortality rate. So a person with a low BMI has a mortality rate of 2. A person with a high BMI has a mortality of 1.5. The ideal BMI, or the lowest mortality is related to a BMI score that's right about average. In any case, people in the middle of the BMI spectrum appear to have the least chance of dying. Use the chart to answer the questions below. So make sure you answer those 3 questions. And if you notice, BMI percentile is up here at the top. Okay. ABSI appears to correct the problem of relating mortality and body size. If you notice, now ABSI, as the ABSI increases, mortality increases. Here's the ABSI percentiles at the top. Make sure you answer those 3 questions. ABSI includes in its calculations not just BMI, but waist circumference and age. So let's look here at my weight, 191, and my height, 74, equals this times 0.4535924, and equals this times 0.0254. My waist in inches is 36, and in meters is that times 0.0254. My gender is male, and my age is 54. Next year I'll be 55. Okay, my BMI is weight in kilograms divided by height in inches, height in meters squared. Okay, ABSI is over here along the side. Equals, I'm going to take my waist in meters divided by, and now open parentheses, and I'll show you why. Take the BMI to the, and you have to use parentheses for the 2/3, close parentheses, times height to the, and you have to use parentheses again, 1/2, close parentheses, and then close parentheses for being in the denominator, and your ABSI should come out to be a decimal. All right, the average ABSI for my age is 0.08. Standard deviation is 0.005, so I'm in the 11th percentile for ABSI. All right, the average ABSI for your age helps you determine if you have a higher or lower risk of death than somebody else your age. In my case, mine's 0.07, which means my category is much lower. If I get a big belly, I'm in trouble, because that will raise my BSI. Let's say that I would have a BMI that would be different than this, or a body that would be different than the ones that say I weighed 300 pounds and had a waist of 50 inches. Now it says my percentile is 1. And if you notice, that's greater than 0.84, so my category would switch to much higher than usual. All right. If I would have a waist circumference of 34 inches and a weight of 190 pounds, If I would get more muscular and less belly fat, notice now my percentile drops to 0.009, which puts me in the much lower category. So you can see the differences in how you go about figuring out how your ABSI score will look.